Okay, thank you for the request to go through question 2, question 4 and question 8 from the spot the mistake worksheet that I showed you. So we're going to go through those questions now. Keep them coming if you have any other questions, whether from that worksheet or from the other worksheet that I put on for you. Now, my top tip really for spot the mistake questions is if you think you can do the question, just do the question, because a lot of the time the mistakes are actually quite subtle, and you can end up sometimes spending more time trying to find the mistake than it will actually take you to do the question. So it might even sometimes be worth, if the question doesn't look too bad, just covering the solution up and then comparing, making sure of course that you do write down what the mistake was that's made here. And in the very first question, if this triangle was an equilateral triangle, then we'd be quite confident to say that e plus 40 degrees must be equal to 60 degrees, and solve that e is equal to 20 degrees. But all it would take would be to substitute e equals 20 into the bottom angle there, 4e minus 5, to show that actually that can't be the case, seeing as substituting 20 into that we get 75 degrees as 4 times 20 minus 5. So there's clearly a mistake here, we can see by substitution, and that's because if we look more carefully at the diagram, it's actually an isosceles triangle. Now with isosceles triangles we're more used to seeing the base like this, and we know that the base angles of isosceles triangles are equal, but there's nothing to stop an isosceles triangle being drawn a little bit out of scale, because if you remember, it often says in a question not drawn accurately, and there's nothing to stop it being given to you on its side like it is here. As long as you're told which two sides are the same length by these dashes here, then you know that it must be these two angles that are equal. And so knowing these two angles are equal, we can say that e plus 40 is equal to 4e minus 5. And then we've just got an equation to solve. Remember, when you're solving equations, line up your equal signs and think carefully about what step you're doing as an inverse operation each time. So here I've got a lower number of e's on the left hand side, so I'd subtract 1e from both sides. So I've got my e's on one side to begin with, and I'll be left with 40 equaling 3 minus 5 here. I then choose to add 5, I think. And I'd get 45 is equal to 3e. And then I'd be able to divide by 3 to find that e is equal to 15. So e is 15 for this question, or 15 degrees. Now you could always substitute that in to check that it works. Here it would make 55 degrees, and here it's also going to make 55 degrees. So you know you've not made any silly mistakes. Now the second question, the diagram shows part of the regular polygon. So really key word there is regular, which means that we know all the sides of that shape are the same length. It's a polygon, so straight edges, and it shows two interior angles of the polygon. How many sides does the polygon have? Well, what the students done is they found the size of an exterior angle was 20 degrees. They've done 180 divided by 20. And they found an answer of 9. Okay, so let's have a think about this. This is actually they're actually very close with their solution there. If we think about the simplest polygon that's regular, I would say the simplest regular polygon, maybe you could argue it's a square or perhaps an equilateral triangle. Now, if I stood at this equilateral triangle facing this way, I decided I was going to walk all the way around this triangle and finish facing in the same direction, then I'd start by turning that amount. I'd walk to this end, still be pointing that way, and then I'd turn that amount. Walk to this end, be pointing this way, I'd finally turn that amount, and I'd walk to the end here, and I'd have been back to where I'd started, and I'd be facing the same direction as where I started as well. If I made this triangle smaller and smaller and smaller, then we've turned that, then we've turned that, then we've turned that. Well, we've turned 360 degrees altogether. And we can see that with any shape, never mind regular shape. It's going to be the same with a square, isn't it? I turn 90 degrees, I turn another 90 degrees, I turn another 90 degrees, I turn another 90 degrees, and altogether I've turned 490 degrees. So I've turned 360 degrees. So this is the exterior angle of this equilateral triangle, so is this, so is this. This is the exterior angle of this square, so is this, so is this, so is this. So what we can say is that the sum of the exterior angles of a polygon is equal to 360 degrees. Now, the fact that these are regular shapes means that they're the same as well. So that's why we were being told that this is a regular polygon in the question, means that we can use that to our advantage, because we know that that if this is the angle here and this is the angle here, we can assume it's 160 degrees for every other side, and as a result that we've got 20 degrees as the external angle, exterior angle rather, or at every point around this shape. Now, you could imagine perhaps being told this for the triangle. You know, let's say you were told that this was 60 and that this was 120. You could calculate relatively quickly by angles on a straight line. How many sides could you have figured out by just being shown one proportion of that? Well, you'd be able to do 360 divided by 120, and you'd get that there must be 3 sides. And we could do the same here, 360 divided by my 4, divided by 90 rather, gives me 4 sides. Well, here we're going to do 360 divided by our 20, and that's going to give me that there's actually 18 sides. So the only mistake that this person's made is they divided by 180 instead of dividing by 360. Now, just very briefly, there is another way you could have done this, and that is, there's not really enough space here for me to do an explanation or a full explanation here, but you could have used the interior angle as well. For if this is just a standard question, we can find out, we can make a link between the sum of the number of angles you can fit into a polygon and the interior angle of that polygon. So if we know the interior angle of this is 160, the formula is that the angle, or the interior angle, is equal to the number of sides minus 2 times by 180 degrees all over the number of sides. So if you remember that formula, you could also have used that here to find out what the number of sides was for this particular shape. So here we'd know the interior angle is 160, and that would be equal to n minus 2 times by 180 all over n. So we could times by n, expand out our brackets and solve. But of course this method is much easier to use there. And as it was a spot the mistake question, you can't just redo the question and get the right answer. You have to spot what mistake was made, which here was that it was 360 degrees that should have been used, and 180 degrees that student had mistakenly used. Okay, so the last question, we might run out of paper here and have to move on, is this one here. Find the equation of the line between the points -3, 2 and 110. Well, maybe it would pay off. What's the student done? They've done the rise of the run, and they've decided that rise of the run, which is the gradient. It's quite good that they've actually said we need to find the gradient there, isn't it? So they've said that that's their calculation for the gradient, and then they've said that they're substituting into y equals mx plus c. So they have done a good solution. It's really easy to follow what they were thinking. So it's not the worst solution I've seen from a student in terms of trying to figure out what's gone wrong. So let's try and apply. Let's try and do their method and see if we see where we've come up short. Now, when you've got a question like this, I would recommend trying to sketch the coordinates. Often that's a good way of just trying and visualize the problem. So -3, 2. Let's say that's over here, and 110. That's a bit further right, a bit further up. 110 there. Okay, so I'm trying to find the equation of the line that passes between those 2 points. Now we should remember that the straight line has the equation y equals mx plus c. So in other words, we need to find out what the gradient is, and we need to find out what the y-axis intercept c is. Now let's start off by trying to find the gradient like our student did in their solution. Well, the gradient, sometimes you might have been told, sometimes in the school you might have been told it's the difference in y over the difference in x, or you might have been told it's the rise, how much you've gone up, over the run. It's how much you've gone up divided by how much you've gone to the right, effectively. So how could I find out how much I've risen and how much I've gone across, or in other words the difference in y over the difference in x? Well, the rise, the amount I've gone up, is going to be the difference in the y coordinates, and how much I've gone across is going to be how much the difference in the x coordinates. The main mistake to avoid though is to avoid mixing up your coordinates. So if I decide to do this minus this, I then need to do this minus this. I can't do 2 minus 10 and then 1 minus negative 3, and I can't do 10 minus 2 and then minus 3 minus 1. I have to be consistent. So the difference in my y I can find by doing 10 minus 2. Let's do that. 10 minus 2. And the difference in my x is going to be 1 minus negative 3. 1 minus negative 3. So I'm going to get 8 over 1 minus negative 3, which is 4. Because that's the same, that's equivalent to 1 plus 3. So I'm going to get a gradient of 2, which I think is what they got. Okay, so we know they're right so far. They've found out that their gradient is equal to 2. Now, we know as a result then, now that m is 2, that that's the ice cream van if you can hear it, is y equals 2x plus some constant c. Well, the best thing to do here would be to substitute in either of these two. Remember that this negative 3, 2 tells you on the lines equation, when x is negative 3, y is going to have a value of 2. And likewise on this equation, when x is 1, y is equal to 10. So I could choose either of these two. Let's see which one they chose and use the same one. It looks like they chose the point coordinate 110, and I think I've spotted the mistake. Have you? They've chosen 110, and then they've done the classic error of saying yx, but think carefully. This is the x coordinate, and this is the y coordinate. And they've mixed them up. So my y would have a value of 10, as that's the y coordinate, and that's when we've got 2 times the x coordinate, which is 1, plus c. So in other words, 10 is equal to 2 plus c, and I can solve to say that c is equal to 8. What can I conclude? Y is equal to 2x plus 8. So this would be a straight line with a gradient of 2 that intercepts the y-axis at 8. And the mistake this time was substituted values in incorrectly. And they mixed up the x and y coordinates. Ran out a little bit of space at the bottom there. I hope that clears up those questions. Please do get in touch if there is anything else that you were stuck on. I hope you also appreciate the use of this. How professional, eh? Really getting the hang of this whole recording videos, like. Thank you.